Hello, good day. Welcome back to this YouTube channel. My name is Godwin. Yeah, your guy. All right. Anyways, we'll be looking at the concepts of probability and mathematical expectation in this particular lesson. We have classes on probability, anyways, but it is interesting to look at just revise a little bit and then take a few questions and then move on to mathematical expectation. So I'm not going to be taking this class as if you guys were novice, right? But then you're still going to get everything that we are going to talk about, anyways. So yeah. Probability is just the science of chance events, right? It's just a science, like the study of chance events, that's all. Now, how do you express probability of a particular thing? So, if you say probability of an event happening, let's say event E happening, is equal to um, the number of times that event can happen, the number of ways an event can happen, divided by the sample space. So, number of ways, that is called N, divided by, that is called H, divided by N. So probability of an event E happening is just the number of ways that event can happen divided by the total, um, divided by the samples, what we call sample space, like the total possible um, number of the total events. So let me just say the frequency of the total events, for example. Right. So the frequency of a particular event happening divided by the frequency of the total event. So there's one event, but there are several other events. So if this event is part of several other events, what is the probability that that event that is part of several other events is happening? So we say okay, it's the frequency of that event happening, right? Divided by the sum of the frequencies of all the events happening. So let's put it that way. So the sum of frequencies of all of the events happening is what we refer to as the sample space, right? Well, probability itself is just h, right? So that's about that. So let's say in the case of a die, right? So you throw a pair of die. So what are the possible numbers that you have on a pair of die? If you ever played Ludo before, something like that. So you have 1 to 6, right? So on a die, you have 1 to 6. So if you ask what's the probability of having a 1 on a die? So how many times can you have 1 on a die? It's just 1. But how many numbers are on a die? You have 6 numbers with frequency of 1. So you have 1 is only occurring once. So you have 2 only occurring once. 3. You understand? So when you throw a die, there's a chance that you can get any of these values. You can get 1 itself, can get something more than 1. So the 6 numbers that we can get with the frequency of 111 is what we refer to as the sample space. So H should be 1 because you have just one appearing just one time over 6. So 1 can appear one time plus 2 can appear one time. So 1 plus 1, 2, 3 can appear one time. 1 plus 1 plus 1, 3. So it gets number 6. That's what we're saying that this is. How about the probability of not having 1? So in that case, we say probability of not having an event E. So it is equal to factorial on it. I think sometimes we put a dash on this, right? Maybe a dash, not having this event, or maybe a factorial an inverted column or an inverted comma on it. So we have this. So probability of E prime is just 1 minus h over n. That is 1 minus the chance that the event does not happen, the probability that the event does not happen. So because sum of probabilities must give you 1, the sum of your probabilities must give you 1. Look at this one, for example, that we talked about here. Probability of 1. So if you are looking at probability of 1, 2, 3, 4, 5, 6, which are the total numbers on the die, so they are respective probability 1 over 6. 1 over 6 plus 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 1 over 6. Right? So 1 plus 1, since they have the same denominators, divided by 6. 1 plus 1 plus 1 plus 1 is 6. 1, 2, 3, 4, 5, 6. And this is going to give you 1. Right? So the probability of not having a particular event is going to be 1 minus probability of having the event. So this is this. So we can just divide this guy by n. I put n here. N will go in n, 1. No, this is going to be 1. 1 in n is n. N times 1 is n minus, we have h. So the probability of not having an event happening equals n minus h over h. Something like that. So that's about that. Now, what is the, I think we're done. Then what's the probability of having two events, having one event happening and the other event also happening? So we call that, you can say, let's say two events. They have event E1 comma, and event E2. So the probability of both events happening will be the multiplication of their respective probabilities. What do I mean? So it's going to be um, P of E1 multiplied by P of E2. So this is what we call the probability of both events happening. So E1 intersection E2. So in this case, now let's say what's the probability of having, okay, we can't have both. We can't say what's the probability of having 1 and 3. If you throw a die, you can't have 1 and 3 at the same time, except you throw two, die, right? Or you throw a pair of die. So that can't work. That can't work. What example can I give? Let me check. What do I have? Okay, there's an example we're going to look at anyway, so it's going to make the whole thing clear. Now, how about this? What's the probability of we have something that we call E1 union E2. So is the probability of having at least one of these events happening. The probability of having at least one of these events. So if what's the probability of having at least E1? Or what's the probability of having at least E2? Or what's the probability of having E1 or E2? Right? So to solve this is going to be equal to the probability of this event E1 plus the probability of this event E2, then minus the probability of E1 intersection E2. So the probability of E1 happening plus the probability of E2 happening, then minus the probability of E1 and E2 happening. Because this E1 here is probability of E1 happening entirely, whether in addition to E2. The E2 here is probability of E2 happening entirely, whether in addition to like E1. So for us to just have like E1, E2, like E1 only, then E2 only. So you just have to kind of eliminate this one there, E1 intersection E2 from it, so I can just be left with this other one. So like this is the way to approach it. That's if you have two events. Then what if you now have three events? Okay, what if you have three events? Because we are going to be solving an example on this. So you have P E1 union E2 union E3. And what we are going to do here is similar to what we do in Venn diagrams. Remember that when we are in Venn diagram, we are talking about probability of I said probability. We are talking about let's say A union B, right? In Venn diagram, we are talking about A union B. So what we do is cardinality of A, right, plus cardinality of B, and minus cardinality of A intersection B, right? So if you look at this guys, the one for probability too, probability of E1 which is like similar to the way these guys are arranged, plus probability of E2, then minus probability of E1 and E2, right? Now for this, if you now have A union B union C, let me write it in, okay, anyway, A union B union C, so I'm going to be having cardinality of A plus cardinality of B, right, plus cardinality of C, then we now begin to have minus cardinality of A intersection B, minus cardinality of A intersection C, minus cardinality of B intersection C, then plus, when you subtract those ones, then plus cardinality of A intersection B intersection C. So if you use this one to find the what do you call it now? The union with A, U, B, and C. So it's just like asking you that, okay, we have three subjects, math, English, and what do you call it, and geography. So how many students take all of these subjects? That's what you're doing here, right? So those that take maths, those that take English, those that, so you add up everything. Then you begin to subtract those that take maths and English, so you remove it. Those that take maths, and so what you're trying to do is to eliminate multiple counting. That's what you're doing by removing all of this. So when you're now done, so there are some guys that will be doing everything. So you add it, and then you get your final answer. So that this approach is what we kind of implement here, because we're solving a question. So this is going to give us probability of E1 plus the probability of E2 plus the probability of E3 and minus probability of E1 intersection E2 and minus probability of E1 intersection E3 and minus the probability of E2 intersection E3, then plus probability of E1 intersection E2 intersection E3. And so just again, just the same idea. So before you are must be attending this class, must have done this around set theory before. So it's just like the same logic. So maybe we should just look at two questions that we can solve, and we apply this particular thing. So let's look at the first one. An experiment consists of rolling a pair of dice, so it's more than one. So event E1 is that um, a 7 occurs, that is the sum of the die is 7. So the event E1, so event E1 on its own. So what E1 is talking about is a sum of die equals, is it die or dice now, equals 7. So that's event E1. Now event E2, right, is the event that an odd number occurs on die 1. So events that an odd number occurs on die 1, only die 1. So we now have a couple of questions to solve. Number one, what's the probability of E1? So what's the probability of E1? So we have to be careful here. Like I said, we've done classes on this before. So let me just do some erasing and then we solve. So we have to look at the sample space because we are drawing, like we are throwing two dice. So it's not just one, right? So the sample space is the first die, 1, 2, 3, 4, 5, 6 are the possible numbers you can get on it. Second one is 1, 2, 3, 4, 5, 6 are the possible number you can get on it. So 1, 1, like one on the first die, one on the second die, one on the first die. So this on and 6. So we continue 2 on the first die, 1 on the second die, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Now this is 3, 1, 3, 2, 3, 4, 3 on the first die, 6 on the second die, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. We have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, and 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are sample space. So we have this, and then we have this. Because they are tossing two dice. So you can have 36 possible combinations. Okay. 36 possible so sum of the die is 7. So how do we get that? Where the sum of the die is 7? 1 and 6. If 1 is on one die and 6 is on the other die, that's 7. So 2 and 5, 7. 3 and 4, 7. 4 and 3, 7. 5 and 2, 7. 6 and 1, 7. Alright, so probability of E1. Probability of E1 is going to be equal to 1, 2, 3, 4, 5, 6 out of the entire sample space, 6 over 36, which is 1 over 6. And done. Then B is asking us for the probability. What's the probability of E2? And what is E2 saying? Event that an odd number occurs on die 1. So probability of E2. What are odd numbers? Odd numbers are, I like that, numbers that cannot be divided by 2. Okay, good. So we are looking at 1, 3, 5 because on a single die, these are the odd numbers there, 1, 3, 5. So you have probability that anytime you toss the two dice or a pair of die, you are going to have an odd number on only the first die, not on the second die. So what does that mean? These are, let me erase this. So this is die 1. Right, so we are looking at 1, 3, and 5. So how many times can you have 1 if you toss a die? 1 can go with 1. 1 can go with 2 on the other die. 1 can go with 3 on the other die. 1 can go with 4 on the other die. 1 can go with 5. 1 can go with 6. So that means for 1 alone, we have 1, 2, 3, 4, 5, 6. Right? Now look at 3. So 3 can, when you toss a die, it could be 3, 1, it could be 3, 2, it could be 3, it could be anything. So we have another 6 here. 6 plus 6, that is 12. Then for 5, it could be 5, 1, 5 on the first die, 1 on the second die, 5 on the first die, 2 on the second die, on and on. So these are under 6. So we are looking at this, this 6 here, this 6 here, this 6 here. That will give us 18. Right? So that's 18. So I'm going to have 18 over 36. which is equal to like half. And I'm not surprised because, of course, you have three odd numbers and three even numbers on a single die. So if you are looking for the probability of odd numbers showing up on one of the die, it should be half of the entire sample space because you only have three odd numbers and three even, so they are equally distributed. Now, C is now saying that we should find the probability of where's it again? Of E1 intersection E2, and it's find the probability that you are going to have a sum of 7, right? And then it's also going to be and then on this thing on the first die, you are also going to have an odd number. So it's going to be a sum of 7, right? So and on the whatever it gets when it does the two die, be a sum of 7. And on the first die, you're going to start with an odd number. It's going to be an odd number. So it will be an odd number, but a sum of 7. Now look at this is odd number 1 and 3, where they have a sum of 7. It's a sum of 7, right? Now we don't use 2, so we come to 3. 3, right, is an odd number and it has to be a sum of 7. So 3 and 4. 5 is an odd number, it has to be a sum of 7. 5 and what am I doing? 5 and 2. So we have 1, 2, 3. This is going to give us 3 over the entire sample space, which is equal to 1 over 12. But there's an easier way to do. Remember, as I told you that P E1 intersection E2 is what? P of E multiplied by P of E1 rather. E1 intersection. P of E1 multiplied by P of E2. But when we solve that out, E1 gave us 1 over 6, so you have 1 over 6 multiplied by 1 over 2, and then of course that's 1 over 12. So you can see it's not a fluke. Now this is okay. Then for D, I think there are like 5 questions here. For D, this is the probability of E1 union E2. Probability of E1 union E2. So what does that mean? So probability that when you toss the two die, you're going to have a sum of 7. And what's E2 saying? Right? And then you toss a sum of 7, or you are going to get event that's an odd number of course on die 1. So when you toss the two pair of die, you're going to have a sum of 7, or do you understand? The chance that an odd number would occur on die 1. So besides, there's a formula for that, right? So what do we do? So you have your P E1 plus your P E2 minus your P E1 intersection E2. So PE1, it was 1 over 6, so you have 1 over 6 plus 1 over 2 minus 1 over 12. So when we find the LCM here is 12. 6 will go into 12 2 times, so this is 2 plus 2 here, 6, 2 here, 1, so we have 7 over 12. And then we are done with this particular question. So yeah, that's how to where is it? So that's how to go, about that. So it's not difficult. It's not difficult at all, right? So the next thing I want to do is the situation where we have 3 events. So how do we approach that? It's a beautiful calculation. So let's just do that and then move into something more beautiful. So for this particular question, a problem is given to 3 students. So we have 3 students are Glory, Rebecca, and Esther. So 300 level students at the moment. So the probability of Glory solving the problem is half. So I'm going to use A for Glory. Or we could use E1 for Glory anyway. E1 is representing Glory. E2 is representing Rebecca. Is it Rebecca? Glory, Rebecca, and Esther. Rebecca. And then E3 is representing Esther. Right? So the question says the probability that Glory is going to be able to solve the problem is half. Right? And then that's the probability that Glory will solve the problem is half. And Rebecca not solving it is 1 over 4. So the probability that Rebecca would be unable to solve it, so that is E1 prime. Right? She won't be able to solve it. E1 prime is going to equal to 1 over 4. Then it says the whole probability of the problem being solved is 63 over 64. So the probability that the problem is solved by any of them, either Rebecca or Glory or Esther. So because it is like that, so you have E1 is the union, E1 union E2 union E3, or equals 63 over 64. So whether Glory is able to solve it, or Rebecca is solving it, or Esther is solving it, so it's 63 over 64. So the question is, what is the probability of Esther solving it? So the question, what's the probability of Esther solving it? That's what we don't know. Right? We don't know. Okay, but we know, of course, that Glory can solve it half. Rebecca, probability that Rebecca can solve it is 1 over 4. Probability. So what we just do is, let's start with Rebecca. So since probability of Rebecca not solving it is 1 over 4, what is our probability of solving it? It's just the other way around, right? So probability of solving it for Rebecca. So probability, is this E1? What am I writing? So it should be E2. So yeah, probability of Rebecca solving it, E2, is going to be equal to 1 minus probability of R unable to solve it. Do you understand? Because those are the possibilities. Either she's able to solve it or she's not able to solve it. And the sum of probability was always equal to 1. It can't be greater than 1. So the chance that an event will happen at best is 100%. The chance that it will not happen is 0%. So we can't say the chance that something will happen is 150%. If it is 100%, it is certain that the event is happening. If it is 0, it's certain that the event is not happening. So the chance of it happening or not happening is going to be between 0 and 1. So as long as it is not certain. So P. So from here, we can just do 1 minus 1 over 4. So equals 1 minus 1 over 4. And this is going to give us a 3 over 4 when you do your math. So now with this, you can use this logic to solve the problem. I use this logic to solve the problem. E1, E2, E3. So we've been given this parameter of either of them solving the problem. So you have 63 over 64. Then equal to parameter of Glory solving it is half, plus probability of Rebecca solving it is 3 over 4, plus probability of Esther solving it, we don't know, is X, right? Then minus probability of, what's this one now? E1, E2. So probability of Glory and Rebecca solving it, so that's going to be equal to, Glory can solve it 1 over 2, multiplied by Rebecca can solve it 3 over 4. Then minus probability of Glory and Esther solving it, that's half, times X, we don't know, minus probability of, so we are done with Glory now, probability of Rebecca and Esther solving it. Rebecca can solve it 3 over 4, then multiplied by X. Alright. So then, what's the last one? So plus probability of all of them solving it. So you have 1 over 2 for Glory, 3 over 4 for Rebecca, then X for this other guy. So 63 over 64 is equal to 1 over 2 plus 3 over 4 plus X minus, this is going to give us 3 over 8 minus 3 over 8 minus X over 2 minus 3 over 4x, then plus 1 times 2, 3x over 8. 3x over 8. What we are actually looking for is just our x. So from here, I think, can we do something here? The common term here is 8. Our LCM here is 8. So 2 will go in 8 4 times, times 1, 4, plus 4 will go in 8 2 times, times 3, 6. This over 1. 1 in 8 is 8 times 8x, that's times x, 8x, minus 8 in 8 is 1, plus 3. 2 in 8 is 4, 4 times this is 4x, minus 4 in 8 is 2, 2 times 3x, that's 6x, then plus 8 in 8 is 1, 1 times 3x plus 3x. So I think you're good. 63 over 64 equals this 4 plus 6 is 10, 10 minus 3 is 7, plus 7, then plus 8x minus 8 plus 8x minus 4x, that's 4x, 4x minus 2x. I'm sorry, this plus 8x minus 4x, 4x, right? Then 4x minus 6x, that's minus 2x. Yes, Then minus 2x plus 3x, that's just x. So you have 7 plus x over 8. So if you understand maths very, very well, you can just do 8 here 1, 8 here 8 is correct, right? So you can also divide the numerators, divide the one here, divide the one here is correct. So, or you can do it your own normal. We can do 63 times 8 equals 64 into bracket 7 plus s, then get the whole thing out. It's fine, just enjoy yourself. So here, I'm just going to do that now. 63 is going to be equal to, of course, this 63 times 1, like cross multiplying, you can cross multiply, as 1 equals to 8 into bracket 7 plus x. So 63 equals 56. 8 times 7 is 56, then plus 8x. So 63 minus 56 equals 8x. 7 equals 8x. Divide by 8, divide by 8. So the probability of x is 7 over 8. So definitely, the probability of Esther solving this question is 7 over 8. Straightforward. Straightforward. So it's not hard. This is one way to do it, right? And there's a second way to, which is also easy. So we can, that approach is using the probability of none of them solving it. So let's just check that out. And let's check that out. The same question. In the first instance, what we did was to, use the normal method. Let's look at the second order method. We've been given that the probability of Glory being able to solve the question is half. So definitely, probability that Glory cannot solve it. E prime. I think prime is meant to be inside. Where is it? Yeah, it's meant to be inside. So you can help me just correct this one. So probability of E prime for E1 prime for Glory is going to be 1 minus half, which is equal to half. So Glory has a 50% chance of not solving it. Now we'll be given that Rebecca, probability of Rebecca not solving it, we'll be giving it as 1 over 4. Fine. Now probability of Esther not solving it. So P of E3 prime. Let's say this is what we are looking for. X, we don't know it, right? So, but we can do something. We've been given the probability of all of them solving it. So, in other words, we've been given PE of E1 union E2 union E3. So, either, the way you read this, either Glory is able to solve it, or Rebecca is able to solve it, or Esther is able to solve it. So, it's union, right? So, equals, we can say 1 minus the probability of none of them solving it, E1 prime union E2 prime union E3 prime. In other words, we could also do this, put the prime outside there. So the probability that they can't, solve it is that. So what can we now do here? So this has been given as 63 over 64. That all of them can solve it. 63 over 64, right? That none of them can solve it. It will be 1 minus the probability that all of them can solve it. So that's the logic that we are using here. So the logic that all of them can solve it is 63 over 64. None of them can solve it is 1 minus 63 over 64. So 1 minus I'm not going to put union there. This is not meant to be union, please. So this is meant to be intersection. So probability of what do you call it? Nobody can solve it, and Rebecca can solve it, and Esther can solve it, right? So probability of this 1 minus 1 of that. So what we are now going to do is 1 minus open the brackets. So probability of this guy can also what is it? That Dory cannot solve it is 1 over 2, and that Rebecca cannot solve it is 1 over 4, and Esther cannot solve it is x. So none of them can solve it. So if we say either Rebecca can solve it or Glory can solve it, or you are not still, that's not like the right statement. So Glory cannot solve it, and Rebecca cannot solve it, and Esther can. So that means none of them can solve it. Nobody can solve it. So like this is what we are meant to write. So I'm sorry for the first error. So 63 over 64 would then be equal to 1 minus, this is a 1 over 8x, right? So we just do over 8. Well, 1 in 8 is 8 times 1, 8 minus x. All right, so 63 over 64 equals 8 minus x over 8. So I could do 8 here 1, 8 here 8. So 63 equals 8 into brackets 8 minus x. No, something is not. Okay, it's correct. So 63 equals 64 minus 8x. So 8x equals 64 minus 63 divided by 8 divided by 8. So x equals 1 over 8. But recall, so in this case, what we did, recall that it's the probability that Esther cannot solve it that we got as 1 over 8. So the probability that Esther can solve it is going to be equal to 1 minus probability that she cannot. So this is going to be equal to 1 minus 1 over 8. Then the answer is 7 over 8. So if you check online, you will see more of this second solution than the first. And I was really interested in like using the first approach, and thankfully a friend was able to help me out with that. And of course, yes, friends help us out. Like, we are not Mr. Know All or Mrs. Know All. Let's see in the next lesson. Thank you very much. Bye.